All right, so let's go ahead and take a look at the review for test number 2. And so the first problem is solve the equation. And I guess there should be a 0 there. Somehow the 0 got left off. Not sure what happened when I printed that out, but we'll make sure that's fixed by the time you print it out. So what they want us to do is do this by factoring. Now, the nice thing is my coefficient of my square term is 1. So I'm just looking at -8, and I have to find two factors of -8 that add up to -7. Since that's a -8, that means my factors have to have opposite signs. Since they add up to -7, the larger number has to be negative. So I can do 1 and -8. And if I add that up, that is -7. So this tells us that this thing is going to factor into a plus 1 times a minus 8. And now I'm just going to set each of those factors equal to 0 and solve. Subtract 1 from both sides. On that first one, it gives us a equals -1. On the second one, add 8 to both sides. That gives us a equals 8. So our two answers are going to be -1 and 8. Alright, so for number 2, we're going to solve the equation 12u squared minus u equals 6. So again, I want to go ahead and get 0 on one side before I start trying to solve this. So we'll go ahead as our first step, and we're going to subtract 6 from both sides. So I'm looking at 12u squared minus u minus 6 equals 0. Now, since my coefficient of my square term here is not 1, it's 12, I have to either use trial and error or the AC method. I'm going to go ahead and use the AC method here. So I'm going to do 12 times the -6. That's a -72. So I want to look for factors of -72 that add up to -1. Well, it's a -72, so one factor has to be negative, one has to be positive. And the larger one has to be negative since it's a -u. So I could do 1 times -72, that doesn't work. 2 times the -36, nope. 3 times -24, nope. 4 times the -18, no. 5 doesn't work. 6 times the -12, that does not work. 7, nope. 8, there it is, 8 times the -9. So those are the factors we want to use. Now, since my coefficient of my square term is not equal to 1, I need to rewrite my middle term using these coefficients and then factor by grouping. So I'm going to rewrite this as 12u squared. That minus u, I'm going to rewrite that as plus 8u minus 9u, and then put our minus 6 equals 0. Now, if I group the first two terms together, I notice that they have a common factor of 4u. So let's factor out that 4u. Our leftovers would be a 3u plus 2. And then if I look at the last terms, they have a common factor of 3. Since they're both negative, I'm going to factor out a -3. My leftovers would be a 3u plus 2. And now if I look at my two pieces, they have a 3u plus 2 in common. So I'm going to factor that out. My leftovers are 4u minus 3. So now we're in business. I'm going to go ahead and set each of these factors equal to 0 and solve. So on this first one, I'm going to subtract 2 from both sides. So that gives 3u equals -2. And now I'm going to divide both sides by 3. On the second one, I want to add 3 to both sides. So that gives 4u equals 3. And then I want to divide both sides by 4. So that's going to give us -2/3 and +3/4. So I'm going to write that over here. So that'd be our answer. All right, let's try number 3. We want to solve by using the square root property. So remember, you have to have a perfect square by itself. And here we do. So we can immediately use the square root property. That becomes u equals plus or minus the square root of 7. And, well, we can't simplify that any further, so we're done. I don't know, I kind of like this one over the last one we just did. So our solution set would be plus or minus square root of 7. So remember, that means negative square root of 7 and positive square root of 7 are our solutions. Number 4 is the same thing, but remember, we have to have our perfect squared isolated on one side, so we need to add 3 to both sides. So that'll give us a squared equals 3. And now use our square root property. And we can't break down the square root of 3, so we've got our answer, a negative square root of 3 and a positive square root of 3. All right, let's try number 5. We have negative 3x squared equals 25, so I've got to get that x squared by itself. So this time I'm going to divide by -3. And that's going to give us x squared equals a -25. And now we're going to apply our square root property. And remember, in this chapter, if we have a negative underneath the square root, we've got to write that in terms of I. So it becomes plus or minus I square root of 25. But now we can simplify the square root of 25. That's just equal to 5. So our answer here is going to be plus or minus 5i. All right, let's turn the page. All right, so the next one we need to solve using the quadratic formula. So let me go ahead and write out the quadratic formula. Again, on the actual test, you should have, as your first problem, should have a formula sheet. On that formula sheet should be the quadratic formula. So you don't need to put it on your note sheet. It should already be there in, on the test. Just go back to problem number 1 and grab that quadratic formula. So let me just write down here. And I guess I should write y since we're actually solving for y, not for x. So opposite b plus or minus the square root of b squared minus 4ac all over 2a. So here my a is 1. My b here is -5. And my c here is -3. So now we're going to plug into the quadratic formula. So for my a, wherever I see an a, I'm going to plug in a 1. For b, wherever I see a b, I'm going to plug in a -5. And wherever I see a c, I'm going to plug in a -3. All right, so let's go and grab a calculator. And when I want to do that whole thing that's underneath the square root, I want to just go ahead and put that in the calculator. Let's see if we can get some more light here. There, that's a little bit better. So I'm just looking at what's underneath the square root. I have a -5 squared minus 4 parentheses 1 parentheses -3. So that's 37. All right, so what we've got here, double negative becomes positive. 5 plus or minus square root of 37 over 2. And square root of 37, we can't simplify. I mean, you can try. Calculator's just going to spit out the same thing back at you. So it can't be broken down anymore. There's nothing that we can reduce, so that's our answer. And remember, this represents two solutions. 5 plus the square root of 37 over 2, and 5 minus the square root of 37 over 2. For number 7, again, why don't you solve by the quadratic formula? Here we have to get 0 on one side before we even start. And it's always best if the y squared is positive. So I want to go ahead and add 6y and 17 to both sides. So that'll give us y squared plus 6y plus 17 equals 0. And now let's go and use the quadratic formula. Here, my a value is going to be 1. My b value is going to be 6. And my c value is 17. So we're just going to plug that all into the quadratic formula. So wherever I see an a, I'm going to plug in 1. Wherever I see a b, I'm going to plug in a 6. Wherever I see a c, I'm going to plug in 17. So going here, and again, I want to put the stuff that's underneath the square root into my calculator. Let the calculator do the work on that. So that gives us a -32. So this is going to be -6 plus or minus the square root of -32 over 2. We have a negative underneath the square root, so we need to write that in terms of I. And then break down the square root of 32. You can do it by hand. 32 is 16 times 2. Square root of 16 is 4. 2 you can't break down, so it'd be 4 square root of 2, or you can make your calculator do the work. That's going to simplify to 4 square root 2. Now when we write this, we'll write this as a -6 plus or minus 4i, can't forget the I, square root 2 over 2. And now I want to divide each term by that 2. So -6 divided by 2 is -3. 4 divided by 2 is 2, so that's 2i square root of 2. So that's going to be our solution set. And again, it represents two solutions, a negative 3 minus 2i square root of 2 and negative 3 plus 2i square root of 2. Let's see if I can write this a little bit better. All right, number 8, we're doing the same thing. Again, we have to get in the proper form. And you have 0 on one side, and I've got to have it in square term plus the term plus a constant. So let's go ahead and distribute this w. So that's going to give us w squared plus 4w equals negative 5. And I'm going to add 5 to both sides to get us a 0 on one side. Now we're ready to use the quadratic formula. So, go ahead and set everything up. Here a is 1. So wherever a is at, I'm going to put a 1 in. B is 4. So wherever I see a B, I'm going to put in my 4. And C is 5. So I'm going to put a 5 in for C. Again, I want to work this out on my calculator. Now I'm just entering it exactly how I see it. Oh, so that's equal to a negative 4. So we're going to have to play with i's again. So that's 4 plus or minus square root of negative 4 over 2. We're going to write that in terms of I. I think my pen's fading on me, so let me rewrite that. So we're going to rewrite that square root of negative 4 as I square root of 4. And of course, square root of 4 is 2, so that becomes 4 plus or minus 2i all over 2. And now I'm just going to divide out the 2. So it becomes 2 plus or minus I. And so that's going to be our solution set. Again, this is representing two different solutions, negative 2 plus I and negative 2 minus I.